This is a very nice looking Philco 89. Here's a back view of it. And I looked around and took a look at the back of the speaker, and I noticed this. This is not looking good. But I thought, well, we'll just take it out of the box and put it on the workbench. And as you can see, the speaker looks a little weird. They definitely used enough caulking or whatever that is on the speaker. But I plan on ohming this radio out and taking a look at the inside here. I noticed that whoever was in here before replaced a couple of caps, but they didn't remove the old ones. And that is definitely a no-no, particularly on any of them, but particularly on the electrolytics. The original electrolytics are still in here, and they just paralleled this newer one on top, so that's definitely a no-no. Here's the inside of the chassis. You can see it's an 89 and a 19. The series is missing, but that's all right. Don't need that. Here's the wiring diagram that I got from Nostalgia Air. And this is the chassis layout here that I'm going to use as I ohm out the circuit. And the main things I'm going to ohm out are the power transformer, the field coil, the audio output, and all the coils, in other words, including the IFs and the antenna coil. And I'm going to start with the power transformer. And what I'm going to do is ohm out these coils. And I'm going to start right at the plug and operate the switch and see if I can't see the primary. And if that doesn't work, I'll put the ohm meter right here, bypassing the switch. And on the secondary, I'm going to put the ohm meter across the plates of the rectifier. Now, previous to this, I have taken out all the tubes and also the dial lamp, so I am not reading through any filaments. And besides, I have to test all the tubes anyway. Also, I'm going to check between center and one side of the plate, and here's the other side of the plate and center. And here's the filament winding for the 80. And I'm just going to continue on checking all the coils. I've got the information from Nostalgia Air. Chassis setup, pinouts, and of course I'm going to be using a wiring diagram. So with these two, help me find the different points I'm going to check. And let's start with the primary of the power transformer. So let's see, turn on the ohm meter and let's see, short this out. Okay, so we subtract about 0.6 from this. Okay, now the primary should be on this plug here. So let me put one side here and one side here. And let me turn on the switch. And I'll get an interesting reading here, like 700 ohms. Hey, turn that off again. Well, it's not open, but we're looking for, let's see, what does it say here? About 7 ohms, 6.8, something like that. Well, let's see. I'll just leave this on, and I'll take one side of this and just looking at this, and let's see here. We got a 50-50 chance here. If I can get that to go there. Nah, that must be the wrong side. I'm trying to go from one side of the transformer to the other through the power cord. Okay. Well, I found the power cord on this side, so yeah, had a 50-50 chance. And of course, Murphy's always watching. I'll put it on this side here. Oh, that's still too high. So we'll forget the cord and the switch. And let's see. On. Get this tangled up a little bit here. Let's try this side right here. There we go. We are across the primary, finally. So that means that we got to do some work on the switch, and we also have to check out the power cord. One side of the switch goes to the primary directly, and one side goes to the switch, and the capacitors down here, the other side goes to the primary. So we are across the primary, and it's reading about 6 ohms. So the primary looks good. Okay, now I'm going to try and get to this secondary. I got the ohm meter across the high voltage secondary, and it reads just under 400 volts, which is just about correct. They're showing 200 on each side of the center. Now, let's see here. If I take this one off and go to ground, it's reading, let that's not a good reading. Let me find a good ground here. Oh, right here. Be a good ground. Oops, meter timed out. Let's see. That's still way too high. Let me go back here. I gotta lift this up here so I can see this thing. Okay, that's right where we were. And ground is supposed to be right here. And that's in the megs. So there's something not quite right about that. Let's see here. Oh, we got a floating ground here. That's why I'm looking at the wiring diagram. Okay, so our electric ground will be over here on the caps if I can find. That's positive, and okay, we'll use this even though we're going to take it out. That's more like it. About half at 177. Okay. Okay, about 190, oh, loose connection. Let's see here. Okay, the other side's about 190, and that's about right. Okay, now the filament is these two. I should have done the bottom one first. Okay. Now, where'd the other one go? Okay. And it should be, yeah, low ohms. Okay, so what I've looked at, although it's taking a little bit of time, it'd be much easier if I was in front of this thing rather than the camera. We took a look at the primary here. That's good. And we've taken a look at this, and then between each one. And right now we are right here, between here and here, which is very low ohms, about 0.6 ohms. I have to remember that we've got this cord here. So let me undo this. Yeah, we have to subtract a little bit. So, yeah, I'd say we're right on it. The paper says 0.1 ohms. So, we've got a good primary and secondary. And I'm going to continue on with this, and I'll check out each one of these. These will probably be easier to get to. And the output, the audio transformer output, and also each one of these coils also, including the antenna coil. Then we'll see if this radio is worth repairing. Don't want any surprises. Now, this is originally what I found. The switch is bad. The field coil's open. The primary of the audio was open. And a feedback coil is open in the oscillator. Well, that may not be feedback. Yeah, I think it's a feedback coil. Anyway, one of the coils in the oscillator is open. That's not good. And another coil is open from the plate of the 44. Well, I decided for some reason to take a look at the back of the speaker and open it up. And this is what I found. I go, holy cow. Somebody got in there, cut the wires, and just twisted them together, and several of them just came apart. This is really amazing. So I decided, well, it's time to test this, and I used two 9-volt batteries to test this. I have two 9-volt batteries that I'm going to hook up to this, and this is to the field coil. You don't hear anything, and this is to the speaker, which hopefully you can hear that. I'm going to put some voltage on the field coil, and it's louder. So it looks like both the field coil and the audio transformer is good. It's just that I don't know how this happened, but if you look close, this wire here is just twisted on, and evidently these came untwisted. Amazing. So this is the result of ohming out all the coils, including the switch. The switch is not operating properly, and We've got 2 coils, one in the oscillator circuit and one in the RF amplifier circuit that is open. And of course, we've got a lot of work to do with the field coil, or rewiring the field coil and the audio transformer. So I'll see what the owner thinks of this. And besides this problem, I'm sure all the capacitors need to be changed out and some of the resistors. So there's quite a bit of work here. Thanks for watching.